So I wanted to do a video on vectors. Vectors are physical quantities that have magnitude and direction. Magnitude essentially answers the question of how much. So it could tell us how far something is, or how far something went, how fast something is going, maybe how strong something is. Magnitude is essentially the number with respect to some measurement, whereas direction just tells us which way that amount is going, or is being applied, or is exerted, it's coming from. We represent them with arrows. The length of the arrow denotes the magnitude. The arrowhead denotes the direction. We graphically add vectors by placing them tip to tail. So if I have 3 vectors, 1, we'll call it A, 2, we'll call it B, and a third one, we'll call it C. And I want to add them together, graphically speaking. I would draw them so that they are tip to tail. And we can place them in any order so long as we keep the direction the same. And what I mean by the direction is if we have some sort of reference, so maybe I'm using the unit circle and this is my 0, the angle has to stay the same no matter which order we add them in. And that angle is always measured from the same reference with respect to the origin of the vector. So again, we can add them in any order, and we should get the same angle. Or sorry, well, the same resultant. See, I can still draw on this one here, and we'll end up in the same spot. This is like the parallelogram method you may have learned in pre-cal, except for more than one vector. And our resultant here, the sum of all these, will have its own angle as well. The reason why we like graphical method, it can help with when we're trying to solve something very quickly, and we don't necessarily need to be quite precise. For instance, if I want to get something that's on a map and try to so if I have a map with a particular scale, so maybe every inch is 10 yards. Then I can say, okay, this is 1, 2, maybe 3.5 inches in length. So the magnitude of this resultant vector is found by converting our scale. So we should get 35 yards. The angle we can find using just a protractor, so we could say 35 yards at whatever degree, we can call that one, let's call it beta. So at some angle from that 0. In some cases, you'll use different reference points. For orienteering, maybe your angle opens up from north. Or if we are throwing something out of a building, then perhaps your angle is from the vertical. Or if we're kicking something off the ground, then perhaps your angle is with respect to the horizontal, with respect to the ground. So as far as the angle goes, just make sure you're giving a frame of reference, so that way everybody understands your coordinate system. One thing I see all the time is people using north, south, east, and west when it's never mentioned. And you can't guarantee that that's the case. Or perhaps when somebody is using north to describe upward. No, north is not up, so that's the wrong direction. And that's all I have on graphical.